in this video we're going to take a look at a special way of describing vectors that we have that works in 2 space that does not work in 3 space. Okay. So, a lot of things that are true of vectors are true in both spaces. One thing that's true in both spaces is that a vector is completely determined by its magnitude and its direction. That's true regardless of what dimensional space I'm in. However, in 2 space, I can actually go one step further. I can say the vector is determined by 2 numbers, its magnitude and the angle that it makes with the positive x-axis. Okay. Now, that's essentially saying its magnitude and its direction. What's special about 2 space is that simply specifying one angle is enough to determine the direction of my vector. Let me just show you why that's not true in 3 space. So in 3 space, here's the positive x-axis. Now right now, I'm holding this marker so that it's making an angle of 30 degrees with the positive x-axis. And you can see that the direction my marker is pointing in is sort of forward and to the right, but with no up or down component at all. Now I'm holding my marker. It's still making an angle of 30 degrees with the x-axis, but the direction it's pointing in is forward and upward. Okay. So knowing the angle that I make with the x-axis isn't enough to determine what the direction is, because I can sort of rotate this around, preserving the fact that I'm making an angle of 30 degrees with the x-axis, but having infinitely many different directions. That's not true if we're in 2 space. Okay. So let's just do an example. Let's suppose that v is a vector in 2 space, and I know that the magnitude of v is 5, and I'm going to just say theta is the angle that it's making with the positive x-axis, and let's say that's 150 degrees. Generally, when we're doing calculus, we will work in radians rather than degrees. But in a lot of applications that involve force vectors, angles are going to be given in degrees. And this section of the book, a lot of the applications that we'll see using this property do involve some force vectors. So I'm going to give this in degrees. Recognize you could be given angles in either unit. Okay, so let's see. I'm going to draw V, and I'm going to draw it in standard position. Now, if the angle it makes with the positive x-axis is 150 degrees, I know that V has to point in this direction. Okay. So, that one angle determines the one direction that I have. In 3 space, knowing the angle that I make with the x-axis doesn't specify a unique direction. In 2 space it does. Okay. All right, so I've got the correct direction, and then I know I want it to have a length of 5. So I would just come out 5 units along this ray, and this would be my vector v, where the magnitude, the length of that ray is 5. Now what I want to do is see if I can find the components of v. I want to write it in bracket notation with the x and y component. I'm going to do that, but I'm going to do that by first of all finding the unit vector that points in the right direction. Now, the unit vector would have a length of just 1. Notice, if I draw a unit vector in standard position, that means its tip is going to be on the unit circle. But I know then exactly what this vector looks like. This would be v hat. That's v normalized. I've shrunk it so that its length is 1. But I know that that's just going to be cosine of 150 degrees, sine of 150 degrees. Because it's pointing to this point on the unit circle. And the x value of a point on the unit circle is the cosine of the angle that corresponds to that location. And the y value is the sine. Pretty cool. Okay. Now I can calculate that further. The reference angle here is 30. So I can say, let's see, we're in quadrant 2, so cosine is going to be negative, and I'm going to attach cosine of 30 degrees, which would be root 3 over 2. Okay. In quadrant 2, sine is positive, and I'm going to attach sine of 30 degrees, so that would be 1/2. Okay. So that's the unit vector that has this direction. And then if I want v, which had a magnitude of 5, I can just say that's going to be 5 copies of cosine 150 degrees, sine of 150 degrees. I just worked out what that is, but I wanted to remind us that's how we got those components of that unit vector. So that's just going to be negative 5 root 3 over 2, comma, 5 halves. Pretty nice. Okay. So I can take advantage of this way of describing vectors if I'm in 2 space. And in the next example, we're going to take a look at how we can use an application of that to find some forces.